Hey, Coach. So I know we've done this before, but can you introduce yourself a little bit?
Hi, I'm Boo Schexnayder. I have a background in coaching elite level track and field. I also do a lot of work in consulting in speed, power, and rehabilitation for a lot of different sports.
Nice. Uh, I'm glad to work under Adam and have some great discussion with him. So the first thing I want to ask is based on the time you're here and what they learned from you. So they mentioned that when you talk about fatigue, there's two stage of fatigue for athlete. Can you explain that about that?
But when it comes to identifying overtraining, which, fatigue is a necessary in athletic training. Overtraining is where you maybe be taking it a little too far. But I can identify typically at least three stages of overtraining. In the first stage of overtraining, the first thing we see is a decrease in fine motor control, which means that sports skills start to erode. You might see a worsening of acceleration mechanics, sprint mechanics, change of direction mechanics. In team sports, this might show itself as hitting slumps or shooting slumps or things of that nature. So that's the first thing you see in an overtraining situation. The second phase of overtraining is one where you see decreases in elasticity and you see decreases in subtle decreases in uh, um, elasticity, but also mobility, flexibility. The In those situations, athletes tend to perform worse on repeat jump tests and things of that nature. Anything that's going to require elasticity and mobility. The mobility issues are tougher to test for, but the elasticity decrements, decreases are actually very easy to test for, and they would identify that second phase of overtraining. And the third phase of overtraining is when power output falls. This, when I say power, I use the term power in terms of explosive power, the ability to produce force quickly. When power falls, you've already moved through some three stages of overtraining. Now, there are many programs that use a power test as a test of overtraining, which is okay to some extent. But if you see power output levels that actually fall, that means that you've already moved through two phases of overtraining. So the power test isn't necessarily the best test in that regard. Now, as far as phase one of overtraining, where we see discoordination and we see lack of loss of fine motor control, I don't know of any technology that'll identify that. The only technology that will really identify that are your eyeballs, because you have to be really sharp and observational in order to identify that. However, what I do with most of the people I work with is that we set up two different sets of jump tests. One jump test is a power-based jump test, like a vertical jump or a vertical jump or a standing long jump or something like that. That is not a repeat jump test. It's more of a single effort power type of activity. The other test is a repeat jump test. It could be a standing triple jump. It could be repeat pogo jumps or whatever the case may be. Some people will do this in the field. Some people will do it on force platforms. But you need a power test. You need a repeat jump test. In overtraining situations, what we see is that the repeat jump test tends to go down before the power test, as we said with our stages of overtraining. So, for example, if I have an athlete that shows decreases, significant decrease in the repeat jump test, but the power jump test is still okay, that tells me they're in the second phase of overtraining. If they show decreases in both, well, that indicates that they are into the third stage of overtraining. So that's how you can kind of gauge to some extent overtraining in using that particular system, keeping in mind that phase one is identifiable with your vision and your observational skills only. Now, this is not to say that there should never be signs of overtraining. If you're an athlete who's training hard, particularly in the preseason or off-season period, you're constantly going to be in phase one of overtraining. And on a fairly regular basis, and you may even delve into stage 2 of overtraining to some extent at certain times. However, it's unlikely that in season, when an athlete is competing on a regular basis, that they should be in stage 2 overtraining and maybe venture every so often lightly into stage 1 of overtraining.
So, if it's for sprinters, isn't they supposed to be like just in stage 1?
Oh, not necessarily. I can see situations in stage 2 where your maximal strength days might drive you temporarily into stage 2. So with a sprinter, so no, not necessarily. I don't ever think under any circumstances you should linger in stage 2 of overtraining. You might touch it and then move immediately out of it. If you linger in stage 2 of overtraining, that would mean that you would your training densities for those qualities would be too high. You would need to train them less frequently to allow more recovery time. Even with sprint types that I coach in specific prep on a Tuesday, they show symptoms of sign of stage 2 overtraining. Typically by Wednesday or Thursday, they're out of that.
Cool. So, if it comes to like technology, like force plate, what kind of metric you'll be looking at when we're defining like stage 2 of overtraining, and what type of metric you'll be looking at when it comes to like stage 3 of overtraining?
Well, like I said, in the force platform, the philosophical approach is no different. So in the force platforms, you would do something like a repeat jump test. Like typically most people will do like pogo jump kind of tests, like either 3 to 5 jumps. A lot of the manufacturers recommend 10 jumps, but I think that's far too many because you'll see power output drops. And what you're looking at as a metric in that situation is you're really looking at the ratio of air time to ground time. If you see the ratio of ground time to air time increase in favor of ground time, then that's an indication of decreased performance in that test. And then, like I said, a simple vertical jump test or something could serve the other purpose.
Nice. So, I want to jump out the like overtraining and ask like, when it comes to like sprinters, I know we probably discussed this a little bit before, but when it comes to like sprinter, is there like too strong for athlete? Like maybe we let them squat too heavy, deadlift too heavy. Is that a thing?
I don't like to use the term too strong because there are so many different forms of strength. Normally when people say too strong, that means that they're only thinking of maximal strength or absolute strength as strength, when that's not true. Power is a form of strength. Elastic strength is, reactive strength is a form of strength. And I'm not sure that you can ever get power or reactive strength too high. There comes a time typically when our genetics seem to limit us in those areas. But as far as the maximal strength is concerned, I don't think there's any question that there does get to a point in speed power sports where if you overdo or overdevelop maximal strength, it makes it difficult for athletes to perform in power tasks and in elastic tasks. The max strength seems to become dominant, and it may be because of proprioceptive patterns being altered or whatever the case may be. It might also have an effect to do on what's going on in the connective tissues as opposed to the muscle tissue. But regardless, what we tend to see is we see inability to progress in power and reactive strength qualities. So what I typically do is I look at an athlete, and it's been my experience that I use squat testing in order to kind of evaluate this. My squat test is a deep subparallel squat. And when I feel that squat reaches to a value of approximately 2.1, maybe 2.2 times an athlete's body weight, then that's pretty good. And to push beyond that point typically produces more problems than it does successes. So in short, once I get an athlete to that point where I see that they are at about 2.2 times their body weight, I kind of say that they're strong enough in that regard. Now, keep in mind that this is for speed power types of tests, speed power types of athletes and such. If I was coaching a power lifter or if I was coaching a sumo wrestler, I might feel a little differently about that 2.2 times body weight because of the difference of those sports. But for typical sprint types in the sports that most of us work in, as far as team sports, track and field, things of that nature, I think that's a pretty valuable a number that'll work.
Nice. So the next thing I want to ask is like when it comes to like develop power or like develop like power, we used to do Olympic weightlifting, and nowadays there's more and more coaches are teaching like Olympic weightlifting derivative like shrugs, clean pull, hang high pull, and we can load these like a derivative like pretty heavy. So would you put that into like your training like session? And what do you think about these stuff?
First of all, I think that variety in training is a necessity. So if you're taking an athlete and you're going to be training an athlete consecutively for 9 or 10 months or so, maybe 11 months or so, then the need for variety becomes a very challenging issue for the trainer. So in these situations, just about every different variation of Olympic lift may be used simply for the need of variety. So this is why you see pulls as well as cleans and snatches and working from the hang position, working from the knee position, working from the floor. All of these different variations all contribute to the variety of training and the need to produce more diverse and more complex training stimulus. So that being said, this is to me the reason why so many of these different variations are valuable. However, there are other reasons. You know, if you look at some of these exercises, if you're looking at need to load, then typically a clean is better because you can lift more weight on a clean than you can on a snatch. However, if you're looking for range of motion, a snatch is obviously better than a clean, and working from the floor is obviously better too, because in those situations, you know, the bar is going to travel a longer path. If you're looking for bar speed, then pulls and snatches are typically better than cleans in those situations. So each of these variations has its own subtle strengths and its own subtle weaknesses as well. It doesn't make much sense to me if it's a day where you want to lift heavy and really low that you go with the snatch. Not that a heavy snatch is a bad thing to do, but it's just not the best exercise to get significant work done as far as that particular type of work is concerned. So that being said, I think I've made a case why all of these things can be an important part of the program. Now, as far as loading is concerned, you mentioned that some coaches are using high pulls and things like this and loading them significantly, possibly as opposed to cleans. There are a couple of reasons why that might be valuable. You know, most of them center around injury risk. You know, if you're dealing with athletes who use their hands quite a bit in their sport, then doing a pull versus doing a clean might decrease the risk of hand injury. It might decrease the risk of wrist injuries and such. So that might be a reason why that type of strategy might be applicable. But I try not to do that on a regular basis because I think the Olympic lifts are a very balanced movement and they develop very balanced forms of strength between absolute and power and reactive strength. There is a reactive strength component involved when you catch the weight. And if this reactive strength is skipped continuously, then we find things somewhat out of balance. So I think there's a lot of value in actually catching the weight in that regard. So that being said, I certainly understand why you might do high pulls. But again, I wouldn't make that my standard practice. I typically do that. What I just said, I kind of manage with certain athletes the chance of wrist injuries and hand injuries by not cleaning athletes at certain critical times of the year, but I'll have them do them at other times when the risk factor isn't significant. So, and also, by the way, snatch is much easier on the wrist than cleans are as well. The last thing I'll say, though, is that when it comes time to really load an athlete, I still prefer a clean to a pull. And the reason why is because if you have to catch the weight, you're going to get a maximal effort out of that athlete. On the other hand, if the athlete knows they don't have to catch the weight, it's easy for them to cheat a little bit. It's easy for them to slip in and drop to a 95 or 97% intensity when actually, if they have to catch the weight, it forces a genuine, true maximal effort. So that's why I try not to use heavy pulls as a genuine substitute for heavy lifting, because it's just too easy for the athlete to subconsciously cheat a little.
Yeah, so by catching the weight, by catching weight, it also increases like reactive strength, like you mentioned. So besides like catching the weight or like doing a full clean, catching the bar, or doing a snatch, catching the bar, is there other like exercise in the gym we can like develop like reactive strength?
Not in that particular way, but there are dozens of exercises that develop reactive strength. So basically, any or all of your ballistic exercises are all developing reactive strength. And if you're looking at slower forms of eccentrics, I think this is where lowering the bar correctly on an Olympic lift becomes important. You know, sometimes I see athletes catch it and then drop it to the floor, as opposed to, you know, lowering it to the floor. And I think there's value in lowering the bar to the floor. I always say if you're good enough to pick it up, you should be good enough to put it down.
Cool. So also, when catch it, because like when it comes to like Olympic lifting, some of it gonna catch the bar with deep squat. Are you gonna catch it like above 90-degree knee angle?
Yeah, I don't typically use the deep catches much. From time to time, I'll have a block of training where the athletes will catch lighter weights deep, but I don't do it on a regular basis. And that's a modification that we typically do as far as using Olympic lifts in training for sports other than weightlifting. Obviously, if you're going to be successful as an Olympic weightlifter, you have to be able to catch the bar in very deep positions. But these deep positions aren't always specific to what we do. And there are other safer, easier to teach methods to in some cases, more specific ways to address these deep positions that you might need when training a sprinter or a team sport player or whatever the case may be, that are a little less, I'm not going to say risky, but a little easier to teach and a little easier to implement than those might be in the Olympic lifting program.
Nice. I want to circle back to the previous question I asked about like how strong is strong enough. And the next thing, I should probably ask this first, but like uh are we gonna like if we load them on like too heavy only on sagittal plane, are they gonna is this gonna affect how they move like horizontal, like multi-directional?
To some extent, possibly, yes. You know, that's one of the issues in genuine speed, power, strength development. The exercise you're using to develop speed, power, and strength are very simple ones, are primal ones. You know, you think of sprinting and jumping as complex movements, but they're very primal movements, meaning that it doesn't require a lot of coordination. It's a primal movement pattern that we've all mastered and such. But when you look at the weight training side of things, the need to load in the weight room to achieve speed, power, and strength increases. The need to load either with speed or strength means that the exercises have to be very simple. You can't be fancy or complicated in your movement patterns and load, or you can't be complicated in your movement patterns and be fast. So it limits us to certain simple exercises in that regard. And that means that we have to find diversity elsewhere in the training program. So it's unquestionable that this is a little bit of a problem, but it's what we have to do in order to be successful. If we're going to achieve speed power levels that really get close to our genetic capabilities and our genetic ceilings, this is a risk that we have to take. So the answer then comes: how do I mitigate this risk? How do I keep this from happening? This is why The other side of your program, your general strength, the general side of the program, your general strength program, your medicine ball work, and your circuit training, and all of these types of things. This is why they have to be multiplanar and rotational in high volumes, is because the limitations we have in diversity on the high end side of the program require us to be far more diverse when it comes to the other side of the training spectrum. So the lower intensity things that you do for fitness, restoration, and so forth, that's where you compensate. That's where you mitigate that injury risk by being as diverse as you possibly can in the movement experiences that the athlete will undergo and the exercises that you as a coach would choose.
Cool. So, I want to jump to the next thing about like stride length. I know we discussed this on the email. So, in order to like develop like I forgot the name, but we used to use like pre-tension to coach our athlete to have like better mechanic at like max velocity. And I used to think that that's probably a way to achieve like a good amount of like good stride length. But like can you like talk a little bit about what is the main reason that gave the athlete the good stride length?
There are many things that contribute to stride length. One is anthropometrics, meaning that taller athletes with longer limbs are naturally going to have longer stride length. So that's one. Unfortunately, we can't develop that. That's a limitation, but that is an important factor. Most measurements of stride length are typically done with respect to an athlete's anthropometrics. Like I think I've read formulas like 2.3 times femur length or something like that is something you should strive for. But in any case, let's talk about the other factors. The ability to produce force is a big one, particularly reactive force. Bigger forces against the ground react and create greater flight times. As a result of that, we see enhanced stride lengths. An athlete that is pre-tense on impact, an athlete that shows good isometric preparation prior to impact, and good eccentric to concentric conversion at impact ultimately is going to show a longer stride length. So developing strength is important, and developing strength in a balanced way, meaning not just concentric strength, but also eccentric strength, is very important in that situation as well. And then there are a couple of important factors in stride length that come into play, and those are related more toward elastic energy production. One is the amplitude of movement, particularly in the hip. For example, when we always think of good sprinters as getting their knees up, but good sprinters also push the knee down through a big range of motion. If you look at a good sprinter at maximum velocity, you'll see the knee come up to about 90-degree position parallel to the ground, the thigh come up to a position parallel to the ground on the front side. And if you look at the backside for a good sprinter, you also see the knee at the completion of the push-off significantly behind the hip. Maybe 15 degrees, maybe as many as 20 degrees or so. So this means that the femur is working through a very big range of motion as we sprint, and therefore that's a big part of stride length as well. The bigger ranges of motion, amplitudes of movement result in increased stride length. And also, a lot of stride length is accomplished because of the rotational factors. If you look at a good sprinter who's running directly at you, if you're looking at them coming to you, you see the knees of the sprinter coming to the midline of the body. Now, this isn't because they're driving the knees across their body. It's because the hip axis is actually turning and rotating and oscillating back and forth in that transverse plane. So this means that this rotation of the hips allows a gentle reaching effect as far as the femur is concerned, not reaching at the foot, but reaching with the femur. And that adds on probably in the neighborhood of 10 centimeters or so to stride length as well. And then the final factor that I look for when stride length is concerned is the path of the center of mass in the sagittal plane. Good sprinters show a slight bounce in the sagittal plane. Normally we think of sprinting as being traveling in a straight line, but that isn't the case. Good sprinters show flight. When they're in the flight phase between strides, they actually go up. And then when they touch down, that's a low point. So we see an actual undulation or a sine wave. The high points of that wave being associated with mid-flight and the low points being associated with ground contact. And so anytime that we propel something into the air at the correct angles, we're going to get enhanced flight. So that's another factor that contributes to stride length. So in short, stride length is dependent upon many different factors, and only a couple of them are training related. Some of them are technically related. And again, an athlete that typically is good technically and strong is going to show the best stride lengths.
Cool. So, in the email we discussed about like you mentioned about like peak force and rate of force development. Is it so when developing these, are you in, let's say, max velocity? For if it's for max velocity, is it like a short ground contact time and like probably vertical plyometrics gonna work better than like power clean?
Yeah, basically, if you're looking for the most specific exercises, that's why a lot of coaches like things like hurdle hops and things of that nature, where the contacts are extremely quick, extremely responsive, and so forth. But I do think that Olympic lifts, once you get above 90-95%, also put a premium on rate of force development as well. So, moderate intensity Olympic lifting probably isn't challenging enough to drive this, but I don't think the Olympic lifts are bad. In fact, I think they're very good for developing this. Now, it is true, it doesn't give the appearance of reactive movement, but it does create stresses on the nervous system that actually help us to achieve improvements in reactivity and diminished ground contact time. Yes.
Cool. So, the other thing I want to ask is about like also relates to max velocity is I know some of the coaches going to develop max velocity through downhill sprinting, probably just a little bit of downhill, like not too, the slope is not too, the degree is not too like crazy. So what are your thoughts on like if we do like downhill sprinting or sometimes they're fatigue? How about like downhill bounding?
Oh, well, first of all, there are lots of different forms of overspeed training, and the effectiveness of overspeed training is undeniable when it's done properly. However, the reasons why overspeed training seems to work typically are misidentified. There's this mindset that if I assist an athlete when they're sprinting, that it's going to help them move the legs faster. And that's not what increases stride frequency. What increases stride frequency is bigger forces, therefore greater degrees of elastic load, producing higher speeds of movement. That's what produces stride frequency. But it's undeniable that certain forms of overspeed training do work. And downhill running is one that can be effective. Now, downhill running on it is the grade needs to be extremely subtle, like a 1% decrease. And I think the reason why this works is not necessarily because of the assistance, but two other reasons. One is that it's a subtle variation of a skill. Motor learning people tell us time and time again that in order to best train a skill, you want to train that skill, but also subtle variations of that skill. And downhill running is a subtle variation there. If the hill is too great, like greater than 1%, then typically we actually see excessive braking forces and control. The athlete starts to seek control. So it's got to be a very, very subtle grade if you're going to do downhill running. For the people who are listening, soccer pitches, are typically flat, but American football fields typically have a crown to them. They're higher in the middle. So if you line up in the middle of the field and run to the angle to the far end of the field, typically that's pretty close to the degree of grade that you would want to have. So it's extremely subtle. And the other effect that might be most important of all is that when you do downhill running, every stride is initiated from a higher position than the next stride. So that means that you have a constant slow fall that's taking place, which means that you have a plyometric effect. So that means that this produces strength. Typically, if you've ever tried downhill running and the grade is really significant, then you find yourself incredibly sore the next day. And that's because of that downhill effect and the plyometric effect that comes along with it. So I think that's part of the magic of downhill sprinting as well, is the presence of the small fall and the plyometric effect that comes along with it. And of course, you could extrapolate that into downhill bounding or whatever as well, if you wanted to.
Cool. But is downhill bounding gonna affect, like, is it gonna put more vertical force into it and turn it into like more braking force?
In excessive downhill situations, undoubtedly, yes. But if you keep the grades to 1%, I doubt that most athletes would even notice a significant difference.
Nice. Last thing before I let you go. So this is I read on the paper. They said that slow twitch muscle have like more connective tissue in it. And when we want our athlete to be like more reactive, more like elastic, shouldn't we train our athlete like shouldn't we use like train more isometric on our slow twitch muscle? Sorry.
Yeah, you're venturing into an area that I'm not 100. I would need to look more at that research, but likening it to something I am familiar with, what we seem to see is that when we train at high intensities with very reactive situations, we see increases in tendon stiffness. And that is very valuable in sprint performance. This is why sprint performances, we typically see really high intensity plyometrics. We see very responsive forms of plyometrics, and we're constantly addressing responsiveness against the ground, quick contact times, and so forth. What this does, it stiffens the tendon, it takes slack out of the tendon, and therefore the tendon becomes more responsive, and we can produce those bigger forces in those shorter periods of time. However, that isn't a quality that's always valued in all athletic opportunities. So if, for example, you were playing in a sport where there was a big change of direction component, where you plant the foot's on the ground for an extended period of time, and then you push off in another direction, that's very different in that situation. And that's why in some situations, exercises like squats and deep squats and things like that, it's best to cut them out of the program in track and field situations, because they tend to produce laxity in the tendons, whereas we want that tightness in the tendon. That's one of the reasons why I normally cut those things out. But that laxity in the tendon might be valuable to some degree in another sport where the top end speed isn't as critical as the ability to quickly change directions and such. So I think this is one of the points where you really have to identify exactly what you're training, why you're training it, and what type of sport you're training for in those regards. This is one of the reasons why track and field coaches often fail in team sport situations, is because they have a bias towards highly responsive types of things. They get their athletes really fast in straight lines and such, but then we find that the athletes struggle in deceleration and change of direction components. Track and field, we don't have any change of direction. We don't have any deceleration events and requirements in those sports. So that being said, it's a matter of identifying, and I think that probably what you're talking about is the tendon stiffness versus laxity that results from the type of training that you use. Again, that's why those types of exercises would probably be of more value in those types of sports.
Cool. Then since like most of the track field athlete like fail to probably fail to like train when they transfer to team sport, they kind of like only train acceleration or max speed. They fail to do the decel. Like, what do you think that you do like make you success at like teams or at the
Well, I think that the key factor there is in the plyometric program to be as diverse as you possibly can. You want some of those high responsive, quick contact type of exercises, but you also want plyometric exercises with longer contact times. This means that you would need vertical work, you would need horizontal work, and you would also need loaded work, squat jumps and things like that of different types. That being said, that means that you want to be able to word I'm looking for here, show a diverse array, a very diverse range of ground contact times in all of the plyometrics that you do over time. In most track and field programs, that isn't the case. Even if it starts that way, there typically comes a time when we're getting closer to key performance times and peak performance times where we're limiting things strictly to very responsive types of things. In that situation, it's about keeping the program diverse for a longer period of time, including the critical competition or peaking times.
Cool, cool. That's all the question I have for you today. Thanks.
Okay, it's always good to see you, Eric. Take
Good to
care.
see you.
Thanks for having me.